All right, well, welcome to another episode of JetTalks. I'm here with my friend Bupender from the award-winning SwissVault. Bupender, welcome.
Thank you, Jim. It's wonderful to be here, and wonderful to be here with you guys at SC25.
Yeah, so what's been your opinion of the show so far?
I'm just amazed by the number of solutions out there. I think the range gives the customers a lot of things to choose for, and getting our heard above the noise is basically the challenge, basically.
Yeah, so tell us a little bit about SwissVault and what you guys are doing.
At SwissVault, we're enabling customers to store lots of data. It comes from our background. We're working with healthcare data, and healthcare organizations, as you know, are basically overwhelmed with the amount of genetic or healthcare data, digital data that's being produced. And then the problem is that they don't have a lot of storage space. They don't have a lot of electrical power, usually in their centers. And they typically don't have a lot of people to help them manage the storage. So if we can simplify that whole process, reduce the space, reduce the energy, that's basically our key modus operandi.
Cool. Why don't you tell us a little bit about how SwissVault is helping, especially I think with the energy use case. To me, that's what's most exciting about your solution.
So the first point is, the way we manage data today, we require to make replications, a backup copy and a backup copy. So this leads to this data bloat that we have to manage.
Yeah, your typical 3-2-1 backup policy, that's in there is the simplistic idea that you need to store your data 3 times.
Yeah, exactly. And I understand it because we're trying to factor into things that things will fail, things will be offline, and data is not going to be available. And our number one job is to make data available for customers, right, when they need it. They don't care how you do it. Yeah. They don't care the background. And so what we're trying to say is that there's a better way. And the better way is what we designed with the file system, number one. It's a kind of a ratio coding methodology. And what it does is it reduces the data volume, so it decreases the data bloat, but it increases the uptime efficiency. So it's if an organization has several servers, that means they can tolerate multiple servers. If they have a risk management policy of saying, what if the building fails, they can spread the data across multiple buildings, or across the country or across countries.
Wow.
Right? And by doing that, we're enabling them to solve a lot of problems with one file system. So you don't have to build complicated stacks. You just do one file system that can take care of data and always make it available. And you don't have to choose between capacity, which is usually the economical argument, versus performance, which is also a high cost argument. And we say you can have both in one solution.
Fantastic. So tell us a little bit about your relationship with the various disk manufacturers and how that aspect informs what you guys are doing.
Okay, that's a very good point, and that actually leads to the fact that media that we depend on storing is always changing. It's changing in capacity, and there's new technologies coming. Hammer drives or shingled magnetic recording drives. Hammer is heat-assisted magnetic recording, and they allow you to produce more density on the same platter. And then, but using them basically means what file system do you have that can really leverage that? And so we were looking at the future, talking to you as well, and your team, and saying, okay, where should we be going with our file system and designing a solution that's future-proof? And the future-proof solution means that we have to tolerate all of these changes or variables, capacity changes, shingled magnetic versus the hammer versus conventional magnetic recording. And so we designed a file system that can work with all these. So all the different vendors, 90% of them is Western Digital, Seagate, and Toshiba. And so they're working with these kind of technologies, and we're looking at them to say, we can build a file system that can use all of these without having to specify what the disk type it is. We just put it into the drive, and the file system recognizes it and knows how to perform, read and write.
Yeah, fantastic. So, SwissVault is essentially unlocking the capabilities of these drives. So we were just at the Western Digital booth talking about their 26 terabyte CMR drives, which is really, as far as I've been able to tell across the board, kind of like where that technology is going to be capped.
Okay.
At least for the foreseeable future.
Okay, interesting.
So kind of curious, not only with traditional CMR versus SMR versus Hammer, but it sounds like SwissVault can also support NVMe and flash storage and various other types of.
Correct. So it depends on who you talk to. people say NVMe is the way to go, and some of those people say no, hard drives, and I believe, or tape drives, and choose your religion, but basically I think all of them are needed,
Right.
and because there's just too much data being produced, and so our file system basically, and we're aware and conscious that customers may want NVMe because it's fast to write to GPUs and send data to GPUs, and we realize that, and so we designed it so that you can tier data up and down between very fast performance NVMe or spinning drives and get lower performance. But actually, with us, as I said, you can get high performance by parallelization.
Yeah, interesting. So is there any particular use cases you guys are looking for your solution?
Well, this one that we talked about, which I still am galvanized by, about infinite storage.
Yeah.
And the idea that, the customer doesn't care how you store the data, they just want the data available. And we talked about the idea of making possible that long-term storage that's self-managing and, self-correcting so the data is always pristine. And when disk drives and other things fail, nobody has to worry about taking care of it. Data gets written somewhere else. You come in and take the least competent person in your team to come and replace the drives. And
that's me.
You're too humble. But basically, yeah. So the idea, the use case is long-term storage. So my background is in genomics, and a genome file, when we were producing them from cancer samples, which have lots and lots of mutations, is a terabyte of raw data.
Wow,
and
really?
It's a terabyte of raw data. And the reason why you have to keep all of it, people say, no, we're just going to compress it down to what is the, kind of the
like the substring.
Yep. Yeah, like basically, the consensus file is what you call it. But I'm arguing that the rare mutations that drive the cancer are these 1 in a 6 billion letter configuration. You have to keep the whole data, and especially in this time when we're learning and doing AI models. I was actually very encouraged by one of the universities I was speaking to here, where they're saying they're building the AI model for genomics,
very cool.
which allows us to do a new discovery. When I was growing up and in the university, they said, whoever figures out how to do protein structure determination will get the Nobel Prize. And indeed, last year, guess who got the Nobel Prize? The guys were working on AI and solved the protein structure issue to some degree.
Yeah, that's what's so fascinating about being in this industry, I think, is just being the infrastructure layer that unlocks the possibility of human progress. Right.
Right. And the same thing's going to happen with genomics. So right now, and probably for the foreseeable future, we're going to need to keep the genome files, 1 terabyte per cancer patient. As you know, in the U.S., the cancer rate is about 100,000 per year. New incidents being developed, so that's 100,000 cancer samples times a terabyte of raw data. You can imagine that's 100 petabytes.
Yeah, per year, wow.
Yeah.
So you guys won a big award recently. Why don't you tell us about that?
Yeah, so we were surprised. We won the HPC Wire Best HPC Storage Product or Technology, and it was the editor's choice. Means the editors got around together on a round table, pull out the solutions that they wanted to pitch, and then defend, and then we were the ones that were chosen by the editors. It was not a popularity contest. It was people thinking about what it is that makes it's going to move the world, right? So we were excited by that.
Yeah, that's really fantastic. Congratulations, guys.
Well, thank you very much.
Yeah, any parting words before we wrap up here?
I think the future is very bright for our industry, where we are, and we're helping the world solve major problems. And I think the fundamental to that is data as a new currency. And along the way, I think we can empower people with their own data to make great changes with AI in particular. But that means helping them to do the custody of the data, the sovereignty of the data, solving the problems that make them more efficient. And we're doing that one customer at a time.
Love it. I couldn't have said any better myself.
Yep.
Bupender, thanks again for being here.
Thank you as well.
Looking forward to working with you well into the future. And that's a wrap for this episode. Cheers.